three applications running. We have X-Plane 10 with an F-22 sitting on the runway, ready for takeoff. We have TinMan RealTime, which has a display set up with a number of gauges that will be receiving sensor data. We have a sensor data template that we've imported for X-Plane 10 that reads the up to 8 to 12 values for any of the 133 sensors on board. And then we have UDP command strings, any of the 1071 command strings that can be sent to the aircraft. And so we'll be using that UDP data source and that UDP data target. We'll be displaying the data through select gauges that we've placed on the screen, gauges and charts, and we'll be relaying the commands from AI Builder through these white rectangles over here. So if you just look at the vertical line of rectangles for managing flaps and trim up and throttle and gear, landing gear and rudder, you'll see these blink as commands are delivered to X-Plane 10. We have the simulator off at the moment so that we can talk without the plane operating. The third application is TinMan AI Builder. We have 4 modules that we've created and put on the screen. The system inputs that will be received from RealTime, well actually from X-Plane via RealTime, are just a select set just to do a minimal liftoff to about level flight at 15,000 feet. And then we have commands and decisions that are made by AI Builder for managing flaps, brake, throttle, landing gear, and then orientation of the aircraft as it moves through the various stages of this flight plan. The flight plan itself is to lift off. It's actually to lower the flaps, to increase speed and thrust to a certain speed, to then pull up, get your liftoff pitch, maintain level flight, bring the gear up, bring the flaps up, increase altitude, and then have level flight at about 10,000 feet. I'm just clicking on the various components here. I won't walk you through the logic within these. What I would urge you to recognize is the simplicity of each of these modules. This in particular is pitch management, and there are 3 different phases, actually 4 different phases of the flight. One is on the runway, that's a level pitch, and then there's the liftoff pitch, which we're just going to set to about 20, and then there's a climbing pitch. After you get to 1,000 feet, you'll climb to actually 10,000, that should be 10,000, and we'll set the pitch to 10, and then ultimately we'll have level flight at above that desired altitude. What we're looking at here is we got a single derivative model of managing the change in pitch and how the aircraft is managed as it moves through those various phases. These right here, these graphical controls, are to simplify the display as you build your logic, and this helps me in particular in designing the demonstration here. And we can consolidate those enclosed components here so that the screen gets even more manageable, so you can modularize the visual nature of your logic if you want to simplify the display. And then here is role management, and again a single derivative model for managing jitter as you move through the different phases, or managing roles so it's not choppy. And so that is the third application. Okay, so we're ready for liftoff. When I click the radar symbols within TinMan RealTime, what that will do is it will allow the receipt of all of the data being sent by X-Plane through UDP into RealTime for visualization, and then also for relay to TinMan AI Builder, and that will then cycle these decision modules to then relay back these decisions on how to manage the aircraft to TinMan RealTime. You'll see these white rectangles blink as commands are executed and then sent and delivered directly to X-Plane. So what I'm going to do is put X-Plane on top. We'll just watch TinMan RealTime, and what we'll probably do is do this a couple times so that you can see each of the applications operate entirely. Alright, so let's go ahead and get started. I'm going to click go, and you'll see the flaps go down 2 notches. You can watch the commands get executed here. This one here is signifying full flaps down.